Alright, I think we live everywhere. What's up, everybody? I'm back again for another coding challenge tonight. This one's a medium from KG.codes, and this is the first one I'm doing, at least in a long time, that's a linked list problem. So it should be pretty interesting. I hope I can get through it. I did it earlier, but we'll see if I can get through it again, kind of retracing my steps and trying to explain it at the same time. And hopefully it makes sense to anybody that jumps in and joins. So I'm gonna give it a few more minutes for people, or a few more seconds, I guess, for people to jump in. Yeah, so I'm gonna try to do this coding challenge. It's called add two numbers, and so basically it's like two linked lists, and the linked list contain two numbers, and basically you're gonna try to add the two numbers together. But the interesting part about the problem is that the numbers are like in reverse order. But I realized that I think that makes the problem actually easier because of the way that you have to traverse a linked list, which is not the same as how you traverse an array or traverse other types of data structures. So this should be pretty interesting, like doing a different type of data structure tonight. I do these coding challenges every Friday live. So yeah, let's jump into it without further ado. Jump into this problem. It's called add two numbers, KG.codes. It's a medium problem, so it's a little bit harder than some of the problems on here. Some people may think this easy if they do a lot of linked list stuff or they've been doing these problems for a long time. But I could say this one's a little bit difficult if you are not familiar and haven't done a lot of these. So it goes as such: you are given two non-empty linked lists. So they're non-empty, so you don't have to check for any edge cases when they're empty. Linked lists representing two non-negative integers, numbers. The digits, and that just means they're like not doubles, so they're not like decimal point numbers. The digits are stored in reverse order, super important. And each of their nodes contains a single digit. So there's not like any nodes in here that have like a 10 or greater in there. It's all less than 10. Which is important. Add the two numbers together and return the sum as another linked list. So the interesting part here is this problem could just be like add these two numbers together and just give me the number back. But the interesting part about this is they want you to actually give them the sum as a reversed linked list too. So these numbers are backwards. So this is really supposed to be 342, 465. Which equals added together 807. And so you may assume the two numbers do not contain any leading zero except for the number zero itself, which is good. I think that probably helps make the problem a little easier as far as edge cases go. But yeah, we'll see. So yeah, they give you this example first with a nice little visual. As you can see, the first number is 243. And then the second number is 564. But remember they said the numbers are in reverse order, so you're really adding together 342 with 342 and 465. So it's like in reverse. 342, 465 equals 807. So that's the explanation. But the output needs to be in reverse order too in its own linked list, which is 807. So or 708 in the linked list order. And so that's the interesting part of this problem. You're kind of looking at it backwards. But if you think about how you think about when you do normal addition, how you add, how you were taught in school to do it. I don't know. Now they teach stuff weird in school now, but how I was taught is that you kind of add the number together backwards, right? You know, you add the ones place, and then you add the tens place, then you add the hundreds place, then you add, and then you have a remainder that you pass over. That's, you know, 1 or 0. You pass that over to the next decimal place or whatever that you need to add. And so if you think about it in a way of addition, how they've structured this problem in reverse order kind of matches the way that you do addition. So when I first started looking at this problem, that's the first thing I noticed. I said, okay, why are they doing this in reverse order? That's kind of weird. But then I thought about it. I was like, oh, they're doing it in reverse order because that's the way you add normally. And so it kind of makes this problem a little easier programmatically. But we'll see how that goes when we start to code it out. So anyway, then there's another example here. 0 and 0, of course, is just going to give you another linked list of 0. And then this is an interesting case too that you may mess up on, or I messed up on. is if the numbers are of different length. So if they're of different length, then you need to add them together, and you're going to have a number of a higher length than one of the, additions, of course. And then if you have a remainder, then you potentially can have another number added on to both of them, like one that's longer than either of them, because all of this is like 9999. So as soon as you add something to it, you get this 8. You basically get like, this 1 million or whatever this is, 1 billion or 1 million, whatever it is. But you got this 1 from a remainder that got added on. So like you need to be able to handle that case in the code, which is an interesting piece that can add some difficulty to this problem. I think that's why they calling this a medium. Constraints down here. If you're in an interview, then of course they may ask you about constraints. They may say, they may tell you the constraints, or you may need to ask the interviewer about the constraints. In this case, LeetCode tells you the constraints. So it's basically saying each linked list is going to have 1 to 100 nodes, which isn't that many actually. And then node value is always 0 or less than 9. So that's super important. So because these are supposed to be decimal place, or like, is it decimal place? Yeah, decimal places or places in the number, and they only can be 1 through 9. Like that's so we don't have to handle any weird edge case for this data being like invalid or something. So each node in the linked list represents just one number inside of the whole number, which that's helpful. And it's guaranteed that the list represents a number and doesn't have any leading zeros. That's helpful too, that there isn't sort of like weird number with like zeros on the front or something that you have to handle, which can make this problem more complicated too. But honestly, it might make the problem easier if they like for this one, if they added zeros on the front, it might make it easier actually. So I don't know, but anyway, that's the problem. I hope that makes sense, is how they described it. Basically, we got these 2 linked lists in reverse order, and we need to add these numbers. We need to treat them as a number, and then we need to add these numbers together. And the result of that needs to be a new linked list that has the sum, like the sum of the 2 numbers in it. So it's a super interesting problem. I thought I'd do something different today. So yeah, let's jump into it. So if you ever seen me do these problems before, you'll know that how I like to do these is think through the solution first in my head of how I would do it, and then try to take what I know from data structures and algorithms and apply that to the solution from my head to try to basically solve the problem. So, and this is the way you want to do it in an interview. Like you want to some degree, you don't want to take too long doing it, but to some degree you want to explain to the interviewer like what your thought process is, get some buy-in from them that like the way you're going is correct. And if you're completely lost, of course you want to do this, and you want to start going through your toolbox of things, of algorithms, and data structures, and trying to kind of work with the interviewer to see if they can. Sometimes they give you a hint, sometimes they won't, but a lot of time, most of the times they're going to say, if you give them a solution like, maybe I should try this, and they'll say, I think that might be a good idea. And if you're completely off, they may try to save you and say like, hey, I don't know about going that way. Maybe think about something else. And so make sure you're talking through, your thought process before just trying to just jump straight into code, because they really can't save you if you just start typing. Like, I mean, they might try, but sometimes it's kind of like so awkward, like they might not. So anyway, somebody said, why do I always see you doing a LeetCode problem I just did? I think I think this is like one of the common problems on LeetCode, like on the first screen. I think I had just never done it before for some reason before today. So anyway, and then website Nicholas, what's up, man, on Instagram. Oh, somebody said there was no sound, but now I can hear you now. So appreciate that. Appreciate for letting me know. Hey, we're about to jump into this problem. So like I said earlier, I mean, it's really not much more than what I said earlier. If I needed to do this in my head, think about when you need to add 2 numbers. When you do addition, if I need to add these 2 numbers, I would add the ones place first. So I would add the 2 and the 5, would give me the 7. I would add the 4 and the 6 would give me 10. So I put the 0 there, but I'd carry a 1. And then I would add the 3 and the 4, but then I had that 1 I carried. So that would be 7 plus 1 would give me the 8. And so since these linked lists are in reverse, what I can do is I can look at my 2 here. I can look at the ones place in my 2 numbers, and I can add them together, and then I get my 7. And I can look at the tens place, 4 and 6. I can add them together. I get 10. I keep the 0, put the 0 in, carry a 1. So I need to store a 1 somewhere. I know I need to store a remainder somewhere in my code. I already know that's coming. And then the last place, I got the 3 and the 4. So I add those together. I get 7, but I can't forget that I had the 1 in the last addition that I did. I carry it over or whatever. So then I get 8. And so then I got a new linked list of 7, 0, and 8, which is in reverse order, which would give me my 807 that I need. And I just return that as my output. So, I mean, I don't think I need to talk more on than that. It's just simple addition, but it's the hard thing about this problem is it's linked list. And linked list is the data structure. It's one of the more complex data structures, harder to kind of keep up with in your mind and understand what's going on in the algorithm. Similar to graph problems and trees, things like that, it can start to get a little confusing versus like simple arrays and other type and stacks and things like that, and hash maps and things like that, which are a little more simple to understand, to traverse and understand what's going on. So we're gonna talk about it. We're gonna try to do this. Oh, the other thing is, like, let's say I got here and I got 10 right here. Well, that means I would need to add a whole new node here with the carryover 1. So I need to be able to make sure I take account of that in my code. So that's one thing I'm thinking about. Or if this number was larger, so this number had an extra node and there's no node here, I basically have to take the value from here and any remainder I had and make sure I just still add a new node down here because I have these are unequal in size. So it's like a lot of node checking, I think, is going to have to be done too. Or I know it's going to have to be done. So, let's try to jump into it and see how we would code this out. So for people that's just joining, I'm going to take this little piece right here. Actually, I'm just going to take this top line and I'm going to jump over to the code side. And I'm going to add it like right here. So people that join, they can see what the problem is. Because sometimes, yeah. And then, so as you guys can see over here, LeetCode, what it does is it scaffolds out the problem for you. So the first time, when I jump on here, the first thing people say is like, why are you using var right here? This is not me. This is LeetCode adding this. So I'm going to change that to const. Yeah. So like those are access, like, not access modifiers, but variable. What the heck do you call them things? Every time I get on here, I forget what the heck you call those. The const, var, and let, what you actually call them. But anyway, somebody in the chat, let me know what you call it. I always forget. I don't know, declaration keywords or whatever they're called. So anyway, I'm gonna change that to const because this is gonna be defined and it's never gonna be changed again. So you are given two non-empty linked lists and we need to add them together. The linked lists are in reverse order and the nodes always contain no single digit, and I need to create a new linked list that has the numbers in both of the two linked lists added together. And so I went through it how I would do it in my head. So now I just bring this to code. So the first thing I said is that I'm gonna have these two lists. I'm gonna look at the ones place and I'm gonna look at the twos place. I'm gonna look at the threes place. The first thing we need to talk about is how does a linked list work? So it depends on the language, but in every language, it's going to have to be some sort of data object that defines a node inside of the linked list. A linked list is basically connected nodes. Some lists can have like cycles in them. Some lists can have multiple, they can be multi-directional. Some linked lists can have multiple connections to different nodes, but in this case, it's a singly linked list. So every node just points to another node. And in our linked list case, we don't have any cycle, like there's no nodes creating some sort of loop, but it's just a singly linked list, and a node is defined as it has a value, a 2 in this case, and then it has a next, like a pointer to the next node, whatever the next node is, a reference to the next node, which is also stored in a variable. So what LeetCode does is they create this linked list function that helps you just create a simple object that defines a linked list. So like I said, every node in the linked list has a value, and it has a reference that points to the next node in the linked list. So go study linked list in your language, in JavaScript or whatever language you use. I'm not going to dig too deep into it beyond that. Like, this is what LeetCode gives you, and that's what I'm going to be using in this problem. And you can see here in their method definition, function definition, they're using the linked list object, and that's what get passed in the two lists that we need to add together. And so traversing a linked list is something else that you also need to study. Is how do you, like, you know how to loop through an array probably if you started programming. You maybe know how to access a hash map, but how do you work with a linked list? Now it's a little bit different. So basically how I like to do it is I like to have a pointer in JavaScript. At least I like to have a pointer that references the current place that I'm at inside the linked list. Similar to when you loop through an array and you have like a I variable that keeps track of the iteration that you're on. You can do a similar thing with linked list and have some sort of variable that keeps track of the node that you're currently on. And since JavaScript, when you assign objects to other objects, it's passed by reference. And so you can basically assign a pointer to a new object and have a pointer to your original, like it's just a reference to your original object. It's kind of hard to explain, but like pass by value versus pass by reference, and understanding that is something that you maybe want to look into if you don't kind of understand that. So what I'm going to do to start off is I'm going to use let, because these will change. I have my L1 linked list and my L2 linked list. I'm going to say L1 pointer, because that's what I'm saying that I'm calling this stuff. And I'm going to just initially set that to, and I might not even have to do that. I might just be able to change this. But the reason I'm going to do this is for clarity later on, which you'll see why I decided to do this. I probably don't have to do this, but it's just going to make the program a little bit more clear to me. So, because I'll know what I'm pointing at all times. So I'm just going to initially turn. So the first thing I'm looking at, when they pass you these, they are passing you what's called like the head of the list, or the first node in the list. So in this case, they're passing me a reference to 2 and a reference to 5 in L1 and L2. So that's something kind of to know. That's how linked lists work. They're going to pass you like the root of the linked list, or what they call the head of the linked list. And if you remember, we're going to be making a third linked list that's going to contain our sum of these two linked lists. So I know eventually I'm going to need like a L3 pointer to point to L3, which I haven't even created yet. So let's create L3. So let's say L3, I'm not sure if this should be a constant now, but let's just create L3. And remember how LeetCode is basically giving us this to create new nodes. So you can do new in JavaScript, at least you can do new node. And then they want me to say what the value is. But right now, L3 has nothing in it. So the value is 0. And the next node is null. I'm sorry, not 0, but it's just null. And so that's going to be my L3. And then I'm just going to say I got a pointer to it. And then the other thing I want to do, this is something important to do in linked list problems, is when you need to return, if I know I need to return this at the end, what I will, I'm trying to see, maybe I don't have to do it. Maybe I can just literally return L3. I think maybe at the end I can just return L3. Or I'm wondering if I need a head, since I'm copying it here. I'm going to try this. I'm going to just try to return L3 at the end, because this is going to be my new linked list. And since I'm copying it from here, I think it'll be fine. So yeah, we'll do it like that. So I have L1, L2, L3 is my answer. That's where I'm going to sum everything together. And then I just got a pointer to, because I'm going to change these pointers as I like traverse all three of these linked lists. And so now the traversal part, now I kind of got my setup how I want it. The other thing I want to do, and you might forget to do this at first, but like I just did it, so I remember to do this. But first time I did, I forgot. But also you want to set up, you remember if we do addition, you may or may not have a remainder value that you need to kind of store somewhere. So I'm always going to keep this kind of like scope variable in here that I can use to kind of like store my remainder. If I add two things together and they go over 10, that I can take the 1 as a remainder. But right now it's just 0. So now we need to traverse through the linked list. And I'm sorry if I'm missing comments and stuff and not answering questions, but I gotta just get through this, man. It's tough. You gotta just think through it and talk through it and keep the mind on it. So appreciate y'all listening to me being my sounding board, working through this. So I'm gonna do a while loop for this, because when I want to end this, what I'm gonna do is keep changing this pointer to the next thing in the linked list for L1 and L2 and L3. And so the point at which I want to stop is when these are equal to null. Like when I basically get to a linked list node where the next on it is null, meaning there's nothing else left in the linked list. So if this is not equal to null, so basically I can just do this in JavaScript. So if I have something in pointer 1 or something in pointer 2, or if I have a remainder, because there's an edge case that I may get to where I don't have any pointers, but I just have a remainder from these two last values that got added together. Now that's something that, the first time I did this problem, I kind of screwed up. I didn't realize I need to keep this remainder, but that's an important part of it, like to keep this while loop going. So the first thing I want to do here is, okay, so I have my L1 pointer, L2 pointer, and I want to get the sum. I want to add the numbers together. So right now, since I'm at the head of the list, I'm looking at the ones place. I'm at the start of the list on each of these two, L1, L2, on each of these two linked lists. And so I can take the sum out of the values out of both of those and add them together and get something. And so what I want to do is basically calculate the sum. So I want to say L1 pointer dot val, because that's how they say you can get the value out, is this variable called val, property called val, plus L2 pointer dot val, and that'll give me my sum. So, and the only problem with this is that, like, either of these can be null. And so what I also have to do is basically do like a null check. And if either one of these are null, then I just want to count it as a 0. So this is kind of like an optimization or an issue that you might run into, that you might miss, and you might try to debug this and have to come back and fix it. But I already know that's going to happen. So L point. So I basically, like, one of these can be null. Like, think of the case if this number is 4 digits and this number is 2 digits, then I may get to the point in the loop where pointer 1 has a node and pointer 2 doesn't, and I just need to treat pointer 2 as like a 0 in that case. Just like in simple mathematics, like if you have a number, you're adding a bigger number to a smaller number as far as number of digits, the smaller numbers, missing numbers, just become like zeros when you do the addition, or you just like ignore them or whatever. But like the same thing as ignoring them is just adding 0. And the other thing is if I have a remainder. So, and now this is starting to get a little bit, I'm gonna try to make this, I'm gonna add the remainder first, and then I'm gonna try to make this look a little prettier. Yeah, so this is remainder plus L1 plus L2 value. And so that'll give me the sum here. And so then now that I have the sum of the two pointers at the first place, I need to put the value into the pointer for L3, because remember, I'm building a third linked list with my values in it. So basically I got the value 2, I've added it to 5 in this case, and I need to put in the third linked list the value 7, which is the sum. And I didn't have any remainder because it just started out. So basically what I want to do is basically say for L3 pointer value, I want to set that equal to the sum. But it's a little bit more complicated than that, because here, do I really want to set it equal to the sum? Because what if it's greater than 10? So what if it's this second case where it's 4 plus 6? I don't want to set 10 in here. I want to set 0 in here, and I want to save a remainder. And so how we do that is modulo, which modulo is kind of, I don't know, it's kind of weird to understand, but basically modulo is going to, it's going to take whatever number, this number is never going to be more than, so it's never going to be like more than like 9 plus 9, because our constraints over here basically say that the highest thing node can be is 9. So the highest it'll be is 18. And so what modulo will do is strip off, it'll basically take whatever number you put here as a 10, and it'll basically like, for better lack of a term, it'll like, maybe one of y'all can explain it in the chat, one of the chats, but for better lack of a term, it's going to kind of like take off the, it's going to take off the 1 that you carry from this number. So if it's like 10, then it's going to put 0. If it's 18, it's going to leave the 8. It's basically going to like kind of pull the 10 out of this number, if that makes sense. So, and I know it probably don't make sense, but that's how modulo works. That's how I know it to work. I don't even know how to explain it, honestly. It's probably something I should learn how to explain, but that's what you need here to basically say when you add two numbers that go above 10, how to get the second digit out of it and just leave that remaining by doing this modulo 10 thing. Basically, I think it just looks at like the 10th place of the number and gives you back kind of sort of like a opposite of a remainder. Yeah, it kind of gives you like the, I don't know, I guess that's how you can explain it. It's kind of hard to explain, honestly. But then just think about the remainder, because I got the remainder variable. So like, do I need a remainder here? And that's if sum is greater than 9. If sum is greater than 9, then I know I need to, and this is a ternary, so it's basically saying if sum is greater than 9, and I can put some parentheses around this to make this look a little bit easier to understand. If sum is greater than 9, then give me 1, because I have a remainder of 1. If sum is less than 9, then give me 0. I don't have any remainder in that case. And so that's how you get the remainder. It's pretty simple. And so really this is, at this point, I've set this value to what it needs to be, and I can just go and start looping to the next one. But the problem is now I need to move all 3 of these pointers to the next place in the number, so I can start adding in the next iteration of this loop. I can start adding. Since this is a while loop, I actually need to do it manually myself. So I know that to get to the next item, I know that pointer equals L1 pointer next is how you get the accessor to the next thing in the linked list. And I know I need to do the same thing for L2. So L2, get the next pointer in the list. And yeah, so yeah, I got the next pointer here for both of these. And then for the third one, I basically, it needs to have something added to it. So I basically need to say, for this one, I need to set what the next is, which will be a new list node. And it'd be null again. And then I need to take, this is kind of confusing. This is when linked list traversal gets a little bit confusing, when you start changing the references. And so basically I created my next node. Now I need to change the pointer to the next node. So it's like you're using something that you're going to change later, which is a little bit different than So I'm basically doing the same thing I did for L pointer and L1 pointer and L2 pointer, but then I have to create the new node because this is my new linked list. The third linked list is the new one, so I need to create it first, and then I can set it equal to this. But there's some caveats to this as well because these, like I said earlier, these can be empty. So if these are empty, I don't need to set them. Like this will actually blow up. So what I can do in JavaScript is use these question marks to basically say if this is null, then just return undefined. So, and if this is null, just return undefined, and then it'll just remain undefined up here until like both of these are undefined. And also the case is if both of these are undefined, then I actually don't even need to make a L pointer 3 in that case. And so that can be a little bit confusing as well. And actually I might just run it just to show what that mistake looks like maybe. But yeah, we'll see. So, I mean, this looks pretty good. So if I'm gonna go ahead and do it. I hope this makes sense. But yeah, basically, if I get here to the end and like there's both of these two things are null, then I don't need to create a new thing here unless one of these exists or a remainder exists. So basically what I can do is actually just take this same if statement from up here. I mean, this condition from up here. Basically take that and say if there's a first pointer, if there's a second pointer, or if there's a remainder, then I know I need to calculate my next sum pointer. And so it's basically the same as up here. If I get up here, and I probably could move this up here somewhere maybe, but this makes more sense as far as logically, like how I'm deciphering this problem. It makes more sense to me to have it down here. So yeah. Okay, so yeah, and so this looks good to me. In an interview, you may be able to run this. You may be in an interview where the tool lets you run this, or you might be in an interview where they don't let you run this and you have to trace through the code manually and tell them like over and over. Oh, appreciate it. Somebody said 25 has a bug. Thank you. Yeah, I'm gonna actually jump this up here like this. I only put this like this because I was trying to save a line, but yeah. So yeah, this is remainder plus the pointer. If it's null, make it 0. And then I actually need to put I actually need to put question mark here too. So that's a bug too, because these could be null, and in that case I also want to get 0. If val is null, I want to get 0. But val should never be null. But it's really if these are null, I want to just make it be 0. So yeah, that's a bug I fixed. So yeah, that's why what you want to do in every interview is at least trace through your code like I just did. Like look through your code to make sure there's no bugs, make sure it works. Now sometimes they'll make you literally trace through it with some input. They'll give you some input and make you trace through it manually. I usually do that on these calls, but I'm not on these lives, but I'm not going to do that because it take a long time, especially for a linked list problem. But what I am going to do is at least go line by line and check my code and make sure it's doing what I think I was planning to do and there's no like typos. So yeah, I got my L1, L2. I create my L3, which is my new list that I want to return. I return it down here. And I set pointers up for L1, L2, and L3 so I can start like iterating through the 3 linked list. I set a remainder equal to 0 to start. While L1 pointer exists, or L1 or L2 pointer exists, or remainder exists. And that makes sense in math. Like if this number has a digit and this one doesn't, you still add. If this one has an extra digit but this one doesn't up here, you still add. And if neither of these have a digit and there's a remainder, you still need to add. So that's why this condition still keeps running if any of these 3 or whatever. And so yeah, so that makes sense to me. And then I make a sum. I need to add my remainder to, that makes sense in math too. You add your remainder to your first value if we have it. So this code just checks if we have a value there. If not, we just treat it as a 0. And here if we have a value here, we treat this as a 0. Or if we don't have a value, we treat it as 0. If not, we take the value out of here. And I know all these question marks look confusing, but it's basically JavaScript. If I didn't write it like this, I'd have to write a bunch of more code to like do null checks on all this stuff. So this is basically JavaScript way of saying like, if this is null, then just give me the 0. If not, then just give me the value out of here. If this passes past this, look at this as like a null check. So anyway, yeah. So then we get down to pointer L3 pointer. The value needs to be set to some modulo 10 because remember I need to take the ones place number off and pass the any remainder that I have, like carry the 1, from like the old school math days, carry the 1. And then here's my remainder. That's what I'm carrying the 1. If it's greater than 9, then I know I need to carry a 1. If not, then I just treat my remainder as 0. And then here is kind of like how I'm actually moving my pointers when I'm moving in the list to the next pointer. So I'm done with all my kind of calculations, but here I just need to say, if this pointer exists, then give me the next, if this node exists, give me the next one in the linked list for L2, for L1. And for L2, do the same thing, give me the next pointer in the list. And then here I check again, if L1 pointer or L2 pointer or remainder exists, that means I'm going to need, when I come back in here again, I'm going to need another pointer in my result, another node in my result, I'm sorry. And so then I basically just say, okay, well, in the next place in here, just create a new node and then set my pointer to that new node. And so this is kind of a little bit confusing linked list style code that you'd have to do a lot when you're working with linked lists and traversing linked lists and doing things with linked lists. So this is just something that might maybe look confusing because you're like setting something, but then you're like replacing this with this when you set it. But this is kind of like the I in a if loop. Like when you say I equals 0 and then it keeps updating. I'm basically manually doing that for a linked list, if that makes sense. And then I return my L3 like I said. So I just went through all that. It's a mouthful. That's why I'm glad I didn't just run through all of that code with the example, because that just take forever. But just be prepared in an interview that sometimes I've been in interviews, they give you a notepad, you write the code, and they expect you to generate an input. Like, hey, get your own test input and run it through this code. Give me a L1 and an L2 and you run it and use comments or use Scratchpad to keep track of the variables and make sure your code works. And the advantage to that is sometimes like you might have the code wrong, and if you explain it well and you make it look like it works, the interviewer is a human. He's a human too. He might miss a typo you have. He might miss some bad logic. But it's really about how you think. In that case, they don't care that your code runs perfectly. They care more about how you solve the problem, how you think, what your approach was, how you talk through your solutions, how you work with them and collaborate, all that stuff. So those kind of interviews are double-edged swords where they don't let you run it. But remember, you might feel bad. I can't run it. I can't debug it. I can't see what's going on. It's a double-edged sword because when you can see when you can run it and you keep hitting run and it keeps being wrong every time, it's a bad feeling in the interview and you don't know what's wrong. So I'm about to do that right now, and I'm about to see if in front of all y'all if this is right or this is wrong. So I don't know. Oh, my boy Ray is on here. The living ETH. What's up, man? He said I definitely want to start doing some coding challenges with my kids to get them started. Hey, I think, man, it's like a valuable skill, I think, going forward. I know everybody say AI is going to take it over, but like, I still think it's, it's one of the last places AI can really reach, just because at the worst case, you can start working to enhance the AI. So I just think a lot of people are thinking like going forward, like knowing how to code is going to start to become more of like a common thing less than it is now. I mean, more than it is now. Where like kids, we already see kids are learning it younger and younger. So anyway, I'm getting distracted. Appreciate you, Ray, for jumping on here. That's my boy. Let's see. So where was I? Yeah, I'm gonna run this. So LeetCode lets you run this. It lets you run it against all the test cases. Man, I got it right in the first try. That's rare. So that's pretty good. So yeah, I expected 708 here. I got 708. Test case 2 is just 0 node. So I got expected 0. And then this is the one where it's like, what is this? Like 9,999,999 plus 9,999. And so you should get, what is this? 8 billion? I don't know. Whatever this is. But it's backwards. So you actually carrying the 1 over here. And oh no, this is like 10 billion, ain't it? 10 million. So you actually had to carry an extra 1 over here. And that's where this this case here, which is kind of hard to see now, but this case here is really important. Like only if you have a remainder, you might still need to carry over. Your linked list is done. Linked list 1 and 2 are done, but you have this remainder that you still need to carry over as like the final thing. And so you'll get like remainder plus 0 plus 0. And then you'll get the value that you want to, the value you want to set. You already did that check here to create the new node you need. You'll set that new node. You'll come down here. You'll be done. Yeah. So, and, ooh, you know what? This code is kind of, because this code right here, the only reason this works is because it's 0. That's the only reason this works. I actually should have like this be like probably like null. Like this code actually be null. But because JavaScript treats 0 as a Boolean false, it actually works. So I actually got lucky there. So I can leave it, but yeah, that's actually just luck. Like if this needed to be another number, my code wouldn't have worked properly. So anyway, that works out. So then LeetCode lets you run it against the all of LeetCode submissions, like other people's submissions, give you like a score. It runs it against a lot more test cases on LeetCode. So we're gonna see what that does. And yeah, so said I beat 77% of other submissions, but this changes every time you do this. So I don't know. Who knows if that's right? Yeah, and then memory beats 64. Runtime beats 77. So let's talk a little bit about that real quick. Runtime complexity. Big O notation is basically how you describe the complexity of an algorithm as it scales, as it handles the scale of input that's coming in. So it's usually in reference to the input size. With this one, shoot, I don't even think I've thought about what the big O is. I think it's the size of the longest list. Like as far as operations I have to do, I have to check. If you look at my loop, as far as what the size of my linked list is that's what can be 1 or it can be 100. It can be, whatever the case is. So I guess the thing that scales with my input here is this loop here. It's the only thing. All these other things are constant operations in big O notation. They get reduced to basically nothing. They're kind of nominal. They don't depend on this. They don't change or they're not affected by the size of my input. But this is. So like however long these linked lists are is how many loops I'll do here. And I'll actually keep it going for the longest one. So if like one of my numbers is like 100 billion or something, then and the other one is 1, then I would have to do the 100 billion. But they say here in the problem that like the linked list is only going to be to 100, so it's really not that long. But I guess it's still linear as far as I would do as many operations here as the longest linked list. So if one of the linked lists is n and one of them is called the length of the first linked list, n is called the length of the second linked list, m, it would be whatever is greater between the max of n and m, which maybe you just end up calling that n and you just say big O of n time complexity. And as far as space, I'm basically keeping track. I'm doing this like at runtime and just keeping track of different variables at each step. That's constant variables. I'm not creating. Oh no, I am creating this third linked list. My bad. So yeah, if you're creating a data structure for space complexity, that's where it comes. If you're creating some sort of data structure that is scaling in relation and correlation to the size of your input. In this case, however long my input is how big this L3 is going to grow, and I'm going to have to return it. And so if it's 1,000,000, then it return 1,000,000. But in this problem, it can't be 1,000,000. But we have to kind of think in big O notation that, whatever the scale is, we kind of have to think about the worst case and whatever the scale can be and have it be like a variable. In some cases we do have to pay attention to the constants that they define as the constraints. But in this case, I think it's safe to say it's big O of n or big O of the greater between m and n. I think probably both of those are correct depending on how you think about it. But let me know what y'all think if anybody's familiar with like big O notation. I think LeetCode has a calculator for big O notation. Oh yeah, so yep, like I said, it's called the first one, size of the first one n, size of the second one m, and it's the max between m and n. Big O of max between m and n, whichever is the longest one. And then the space complexity is the same thing, like I said. So cool. So I guess it's what do you want to call it? Like if you want to, it depends on what you define m and n. Because you may just say, okay, I'm going to define n as the max between m and n. Then you would just say this is big O of n, or whatever. Or I don't know. I guess you could define it differently. But I guess this is technically right. This is probably what an interviewer would be looking for. But they probably would be, I don't know. I just feel like if I was doing an interview with this, I'd be okay if they just were like big O of n. But that's just, if they called out the fact that it's the bigger between the two linked lists, and they said big O of n, they said it's linear, then I'd still accept that if I was given an interview. So anyway, that's the problem. That's it. This one is called add two numbers. That's how you do it. I like this problem. It's like a linked list problem. It's a pretty cool linked list problem, like adding these two numbers together. It makes sense to me. The solution makes sense to me. A lot of these LeetCode problems you'll get through them and you're just like, man, this was so hard. And I didn't like the problem. I didn't understand it. It didn't feel like it was working that muscle that I want to, grow or whatever. I want to improve as far as LeetCode and coding challenges. So, but this one does seem like it's like a good problem to kind of understand kind of like how to do logic around pointers and singly linked list, and kind of like working your mind around like a good entry level to some of those types of problems, linked list problems. So I hope that makes sense. I appreciate people watching. My boy Travis joined. He might be still on here. Honcho, Mr. J Honcho, what's up, man? I used to work with him. Serenity First, what's up? I always follow her for a long time on Instagram. Bunch of people joined. Boy, Photo Logic, Darius joined again. Appreciate that. Vanessa, my wife, joined, so I definitely appreciate that. Dexter, my boy, joined. Appreciate you joining. He on his code and grind. And yeah, I appreciate everybody on TikTok as well. I'm on all different channels, so I'm on Instagram, X, Facebook, Twitch, YouTube, and TikTok. So I'm everywhere. Live when I do these every Friday, so you can come back and find me. every Friday at some time during the night. I usually do it from either 7 to 10. I'm gonna try to maybe get more consistent with the time, but I don't like being time blocked for stuff. So, cause I got a lot of stuff to do. So I ain't got time to be, and I ain't so busy. I ain't got a lot of stuff to do, but shoot, I just don't. Hey, I enjoy my free time. So that's considered stuff to do for me. So anyway, yeah. Let me know if you have any questions. I'll probably answer questions for a little bit and then probably let y'all go. Somebody said, never mind, MVM. I don't see any questions on TikTok, so I guess that means everything cool. I usually get a bunch of questions, comments, but I think I probably, doesn't AI have an inbreeding problem? I don't really think there's nearly enough data out there. Yeah, I think we'll be fine. Yeah, Jicky, something like that. Yeah, I think we'll be fine, man. We just gonna have to adapt and try to just take it year by year, day by day, step by step with this AI thing and figure out kind of. I always have confidence that, skilled people, as long as you can continue to build skills, just like my boy talking about he's getting his kids to code, as long as you continue to build skills, that I feel like the people that build skills will always they'll always kind of rise to whatever or adapt to whatever situation they need to continue to kind of be successful. So same as it was when, back in the day, people were scared when Google came out and when the internet came out. Programmers were scared back then. They were like, well, now people can just look up the information on the internet, and now people are going to come in and flood the programming market and take my job and blah, blah, blah. So every time there's a big advancement, we get scared. Now, AI, that's a big one. I ain't going to lie. Like, AI, it's a pretty scary one because, like, it's, like, exponentially growing, and it's, like, you think about 4 years ago, we weren't even thinking about AI like this, So, within these last couple years, it's been crazy. So imagine what 10 years from now, what things gonna look like. So just gotta take it day by day and just keep building skills, man. Because there's some skills it can't cover still. Like the stuff I was dealing at work today in my day job, ain't no AI gonna deal with it. Like I didn't write one line of code today. I looked at a lot of code, I reviewed code, but I made a lot of technical decisions, talked about technical decisions, planned stuff for the future. It's like some stuff just AI just, at least not yet, it can't do. It can't have a memory and a history of, and sometimes the best technical decision ain't always the decision your customers want. It's not always the best decision based on the circumstances, the resources you have, or the context that you're in. So, it is what it is. Yep, I heard IT guys were scared of Google back in the day. Yep, I heard that too. I heard that from literally like older dudes in the industry that I was working with that was like started their career in like the 90s, and internet and Google started coming out. They were scared. Like they were like, this is gonna mess everything up. And so just like we feeling now, like this AI thing is gonna come screw us up. And why I preach about it, like, is not because I'm okay. I think I'll be all right. Like I'm kind of in the middle of my career, and maybe coming towards closer to the end than I am to the start. I don't know, but and maybe not close to the end, but I feel like I'm in the middle, and so I feel like I'll probably make it, to the end of my career. But it's people that just don't even want to start. They so scared about the AI stuff that they just won't even start programming. Like they literally saying like, I'm not gonna join the industry. Like they being scared out of the industry due to AI. And it's like, if you scared out of programming due to AI, then, and I'm almost tired of talking about the AI, but like if you're getting scared out of programming, then you should be getting scared out of any career. You know what I mean? Like Elon got robots he building in his Tesla factory right now that basically if you add AI to those, or if you added AI to those, they can do almost any job. They're good. If the AI gets good enough and their robotics get good enough, what job can't they do really? Like could they eventually be just walking around a courtroom as a lawyer, or doing? Would you prefer a doctor that has a robot doctor that has 100% success rate versus a human doctor that makes a mistake and leaves the knife stuck in you and sews you back up with a tool in you, versus a robot that can like literally digitally detect within a microsecond that something is wrong, so it's scary, man. I mean, for everybody. So like, I mean, I wouldn't over worry about programming too much. That's my whole point of saying all that. So anyway, somebody said more money for us. Hey, man. I mean, I guess it keep the competition down. I mean, I guess if I want to look like it like that, I mean, hey, it is what it is. But I'm gonna keep trying to encourage people to get into this thing because it's been good to me in my life as far as the tech industry goes and programming and stuff like that. So I try to encourage people to get into it. And even if you're not in the tech industry, just like learning just a little bit more, like learning to code is a super valuable skill. Like no matter, I feel like even if you learn a light level of maybe how to just do JavaScripting, using JavaScript to write scripts in the browser, like just very simple stuff. Even if you just learn that, like it can separate you from people at work. It can separate you in your other career. It's also a great skill to have combined with another skill. Like one of my friends, he's an engineer and he went to like a boot camp to try to learn how to code and learned how to code. And so I feel like it's a great thing you can have like in your back pocket if you have the time to do as a kind of a side skill. And so like you're in one industry, but like everybody's like, man, our program isn't working. And imagine if you can go and just like kind of code a solution or go fix a bug or make a whole new thing. Imagine what that does for your career in your own industry, So, it just depends on what you're doing, I guess. So, yeah. Do you recommend reading code and tracing it in order to improve? For sure. Like to get better at code, you need to be looking at a lot of code, like documentation, reviewing code reviews are some of the best ways to learn how to code. Doing code reviews and getting code reviews are some of the best ways. You need to be reviewing your old code, reviewing code from articles and tutorials, like for sure. Like tracing code, definitely for sure. Like and tracing code by hand. Like sometimes you literally need to just don't run it. Like you just need to look line by line, like I was doing earlier, and just literally try to determine what the program is doing, because sometimes you'll run it and you can't see it. And so just being able to do that and like is super important. And then for interviews, yeah, you might be made to do it. So I have 36 credits so far in computer science, started this year as a freshman. Hey, good luck. Keep going, man. 36 credits. That's good. Shoot, I ain't been in school in so long. I mean, that's more than a semester. So, hey, man, you're on the way. Just keep going. Keep pushing. How do you recommend studying and improving your coding? I mean, there's so many resources on the internet, YouTube, boot camps. I still recommend going to school. I never will stop recommending going to school if you can, if it makes sense for you. But I also recommend boot camps and self-teaching with resources online. There's so many resources that I'm not even, you have to really DM me with some details. And I encourage anybody to DM me if they have questions, but about what specifically you're trying to do, and I can give you some specific resources. But I would give you the tip of make sure you're not only just studying resources and doing tutorials, but at some point you actually start coding coding real projects, like trying out some real mini projects that you are interested in. Because it's something about doing a real project and running into real problems that you're not going to run into problems in a tutorial. It's always going to work perfectly. But it's something about running into problems and dealing with problems and then going to try to find the answer either with ChatGPT, Stack Overflow, Google. That's what the programming job, a lot of the programming job is debugging issues, and not just debugging, but trying to figure out solutioning. Like at the end of the day, programmers are just problem solving with the lens of coding and software development. But at the end of the day, our tool is coding. But at the end of the day, we're just solving problems. Like we're just solving problems with software. So like getting to a point where you're starting to do more problem solving stuff, because you'll be shell shocked when you get to the job if all you've been doing is a bunch of tutorials, if you can get into the job. So that's one thing I'd say to do is, in addition to your learning, boot camps, probably not boot camps, because boot camps make you do that's why I always recommend boot camps in school, because they make you problem solve, to a degree. But especially if you're self-teaching, like definitely you need to kind of do your own projects to create this sort of like I'm trying to make this app, and I don't know how to do it, and I need to go like research deeply how to do this thing. And so, anyway, yeah, that's a good question. Getting back into my next job, had last internship last summer. Hey, that's what's up. Getting back into it to get my next job. Hey, that's what's up. So you getting back on the interview grind. Yeah, good luck, man. Just keep your head up, man. It could be a long journey. It may go quick for you, hopefully. That's what I'm wishing for you. So, but yeah, that's why I'm practicing these, just to stay interview ready. But I'm not actively interviewing right now, but I'm just trying to stay ready, man. I always stay ready. It gets easier over time. Yep, it gets easier over time. Like once you start, something clicked in my mind when I first was in school and I was just struggling. I was like, man, there ain't no way I can do this as a full-time job. Like I'm struggling. I'm making bad grades. I don't understand what's going on half the time. I'm barely making it through. And then one day something just clicked in my mind, man. It was just like, it just started making sense. Like it was enough school just forced me enough to look into the stuff enough to where finally one day it just made sense. Like it was when we started doing object-oriented programming with, I think, Java. And it was my compilers class. And we had to make classes and we used inheritance. And that's when it started to make sense. I was like, dang, this is why you need classes. This is why you need inheritance. This is like why you need this stuff. Like because it just felt like school mumbo jumbo at first. And once I started using it in compilers class, I was like, oh snap, this is programming. This is what it is. This is how it works. And then once you get that click, then it's like, it's just off to the races. Then it's just, you just learning more and more stuff, but you kind of understand the fundamentals. Data structures and algorithms was probably one of those classes too that helped me too. But that class was so damn hard, man. I couldn't really appreciate it while I was in it. But afterward, I was like, dang, this is the class you need for the interviews. This is the class you need to really understand data structures, that like stuff I'm doing right now. This is the class. But I couldn't appreciate it at the time because it was so hard, man. But it really was probably the best, if not the best class as far as applicability that we had at school. That in addition to the compilers class. And I'll probably say there was a software development project class where we just worked on like a real project the whole semester, which was pretty cool. I'll probably say between those three classes, those were probably the best as far as like being something I still look to today. I love data structures and algorithms back in the university. Initially gained my confidence. Yeah, that makes sense, man. That makes sense that would be the class to do it. Cause that's probably should have been the class for me, but I took that class twice, man. I was still in my struggle period at that time. I barely got through that class the second time, actually, barely got through it then. But then, yeah, something about when I got to that next class, that like all that stuff from the previous class started to make sense, and I really don't know what it was. The only thing I could think, it was the object-oriented stuff, and we were actually building something like. The whole semester was building this compiler, like a compiler that actually, we had like a fake language and we we're actually building a compiler that can compile code from the fake language that we made. So that was pretty cool. Everybody else hated it, but I thought it was cool because that's when everything started to click for me. And then at the university, programming became like my fun classes, and all the other electives and the general education class I had to take became my like boo-boo classes that I was just like, man, I hate these classes. I started hating every other class. But when I started out, programming classes were the hard ones and the ones I hated. So it's crazy how it flipped, where those became like my favorite class. Like I was turning in my assignments early. By senior year, I was turning in stuff early. I turned in from the problem student to the class favorite. Like I was like I wasn't kissing up, but it was like I was literally walk up in the class. I'm like, hey, I got my project done. And just hand it to her. And she's like, what? Like, are you serious? And it's like, yeah, shoot. I mean, hey, I got on it last night and I was just going. So it's something clicked, man. I don't know what it was, but something clicked. But yeah, I'm not even bragging because like before that, man, I would be sleeping in the class. I remember one class, I hope she don't remember this, the teacher, because I think she's still there, but like, I used to sit next to the wall and I had like hair grease in my head, and I slept so much in that class that by midway through this, I ain't gonna say midway through the semester, by like a quarter of the way through the semester, it was a big grease stain on the side of the wall where my head kept sleeping. I'm like sleeping in this lady's face, like every class. Like I'm like sitting like 2 rows, and I'm just knocked, my head banging against the thing, and I'm asleep. And then I leave, and it's a big grease stain that everybody could see, and everybody's like, what's that stain? And that stain stayed there until they like replaced the whatever was on the wall right there. It was like some kind of it was like a pegboard, and so the grease got into like that little pegboard material. That joint was crazy, man. Like, and then I barely passed that class, but yeah, I would sleep every day in her face, man. Like, I would have just kicked me out. I ain't gonna lie. Like me today, I wouldn't have took that. I wouldn't have stood for that, cause that was disrespectful. I ain't gonna lie, but she stayed with me. By the time I got to that last class, I was like turning in stuff early. I turned from like, and she was a hard professor, man, but I appreciate her now. But yeah, that was tough, man. But I turned it around, so hey, that's all I can say, man. I was a problem student. I was like lowest. I was bottom of the barrel. I was close to bottom of the barrel in the computer science department, for real. Like I wouldn't say bottom of the barrel, because we used to have a computer lab, and everybody would like, basically computer science students lived in the computer lab. And it'd be people in there just trying to do that. They didn't know nothing. They just literally trying to get in there and copy people's homework. They just in there like, you know, I hate to say it, they in there like leeches, man. Like they ain't have no desire to learn nothing. They just literally came to the computer lab to see who was in there and see who they could bum their homework off of. But like they literally had programs even back then to detect if you were stealing people's stuff. And then you definitely couldn't steal their files, but people, like, if you left your computer sitting there, people would literally go on your computer, put their flash drive in, and take the files off. If you were like playing around you left, go to the bathroom, or you were playing around, like people literally would steal your stuff and halfway get you in trouble. Or they just sit there and you trying to explain it to them, trying to help them, and they just sitting there just typing from your junk, just like, and I'm like, dude, like, she gonna know you naming the variables the same, man. Like, change the variable names at least. Put the different lines, change the order of the functions. Like, anyway, man, people was just tripping. But yeah, that was the computer science days, man. But yeah, I got through it and got on to my career, and everything's been pretty cool since. The sleeping students are the smartest cookies. Yeah, I guess maybe I was dormant, man. I was just dormant for a while, and I just had to wake up. Maybe that's what it was. Pass the class versus attaining the knowledge. It was a lot of classes in school that I just passed. Said, bro, forgot the do-rag. Yeah, man. See, I wouldn't like that. I wasn't going to just wear no do-rag to class. I don't know, man. And I had waves back then. Like, I didn't have this little scruffy stuff that I had, like this new style or whatever. I had, like, short hair and waves, so I didn't like to wear a do-rag. I mean, I would take the do-rag off to go to school. And I had the grease in there, and it was just like, I just lay that junk on the side. I just fall asleep to the side, like just straight up. Like, I'm talking about, that was some good sleep. I ain't even gonna lie, but it was bad because I just don't see how she taught that class and looked at me sleeping. I guess she just said, she was just like, he just not gonna be nothing. Like, the only thing I could think. But the crazy part, I ended up making a C in that class. Like, I literally, I guess I had enough to pass the class, but it was like, you know, I don't see how, man. I don't see how she just didn't say, hey, man, get out of here. Like, but I respect her for that. I'm glad she didn't, because she held me in there. So shoot, man, see if I missed any questions. I like this. Thank creator, appreciate you joining, man, and saying that. Somebody on YouTube said make a Spotify clone. I might do that one day. I might do that on live one day. Make a clone. Like, do a project on live. Cause yeah, I feel like I've been doing a lot of these problems, but it would be cool to go in and do a project one day. I've done it before, but it's more or less like never end to end. It was just something I'm already working on. I just kind of shared that night that I'm working on it, but I might do that, and I might do Q&A again, where I just get on here and just do questions the whole night, or the whole time. So just let me know. Just DM me, man. If like anybody DM me if you have questions about anything, no matter where you are in your career. Some of y'all are ahead of me. Some of y'all maybe just getting started or whatever. And it's not really a head or behind thing. Everybody got different levels of knowledge in different areas. But maybe there's something I can help you with. Maybe something you can help me with, whatever. But just DM me. Make connections with each other as well. Like that you find people interested in the chat. Like it's a decent community on these platforms. It ain't perfect, but I've gotten a lot of value from being on social media the last few years in the tech space. So it's cool to connect with people, and it ends up leading to things. Like, take it from me, it definitely does. So I appreciate y'all joining. As always, it's getting late here, so I'm gonna sign off in a minute here. Appreciate you guys joining. Follow me on all channels that you watch and subscribe to. I post content. I do these every Friday, some sort of live every Friday. And would love to connect with folks. And that's pretty much it. So I hope y'all have a good weekend and a good night, and I'll see y'all next week. Appreciate it.